Now the next thing I want to look at is increment and decrement. So what do we mean by that? So let's say that I have a variable a, right? Now what I want to do is I want to increase the value of a by 1, and I can do that by using this line of code. A is equal to a plus 1, right? So what this will do is it will take the value of a, which is 6, and then add 1 to it, and that's going to return a 7. So let's go ahead and rerun this code to see what the output is going to be, right? And we have a 7 over here. Good, so we're good to go. Now what I want to do is I want to shorten this format, and we know the first way is I can put the operator here, which is a plus, and then delete all this, right? And we have a 7 over here. Now what this decrement and increment allows is to just say a plus plus, and then go ahead and delete all this. So a plus plus semicolon, and it will do the same thing as what this would do, as what a is equal to a plus 1 will do, or we can have a plus equal to 1. Yeah, so this is the same thing. So let's run this and see what the output would be, right? And we have the 7 over there as well, so it means that we have done the right thing. And we can also decrease it, and this we can only decrease it by 1. So a plus plus increases it by 1, and then a minus minus would decrease it by 1. So let's go ahead and run this, and we have a 5 over there, right? So we have decreased it by 1. So this is a short format of doing that. And the next thing we would want to look at is possible errors in using this format. Now over here what I have is an integer a equal 9, and then I can have this piece of code over here, which is plus plus a. Now let's use a plus plus. Good. So now I have an integer a, and a equal 9, right? It equals 9, and you know that this would increase the value of a by 1, so the new value of a will become 10. To be sure, let's print this out before we continue. So we have a over here, so let's run this line of code. So we should have a 10, and we have 10 as the output, right? So we've done the right thing. Now I created a second variable b, and I equated it to, let's use this format first, a plus plus, right? So now what will this do? So we'll run it to see what will happen. Sorry, I did not print out the value of b, so let me just go ahead and print out the value of b. So see out b, right? And let me make sure that this is it's graphically presentable, so we can have this over here like this. Good. And then I think we should print out a as well, right? So we would have, after the end line, then we should have the string a colon the value of a, then we end it there. Yeah, so we run this and we have, whoops, what did I do here? Okay, so let me clear this line of code because it's interfering with what we're doing. So I'll rerun this so that we get the correct graphical representation. And now we have b 10 and then a 11, right? So what, whoops, I should clear this line. Even though I could have explained it with that one, it will not be, you will not get what I would want to say. So let me explain this whole concept again. So we have an integer a, which is equal to 9, and then we know that this piece of code would increase the value of a by 1, right? Good. And we are assigning it to a new variable b. There's something I want to talk about here, so let's just run this line of code and see the result, and make certain changes and run the code again and see what happens. So b is 9 and a is 10. Now what happened over here? So before the assignment to b, the value of a was 9. So 9 was assigned to b before a was increased. So after the assignment of a to b, so b was 9, and then after that a got increased by 1. So the new value of a became 10. You might have thought that b should have been 10 as well, because since this would increase the value of A by 1, which is going to be 10, and after that we got assigned to B, then B should be 10 as well. But that was not the case. So if you want that case to happen, then these plus plus signs should come in front of A so that A would be increased before the assignment to B. Right, so let's run this piece of code and see if we will get the desired output. Right, so I'll go ahead and run the shift B, and now we have B as 10 and A2 as 10. So what happened here was that before the assignment of A to B, A was increased by 1 first. Then after that increment, it was then assigned to B. But in the initial instance, where the plus plus came after the A was assigned to B, but then the value of A at that time was 9. So B was 9. And then after that assignment, then the value was updated by 1. So that was what happened. So be careful over there when you write this, when the plus signs come before A and when they come after A. Be careful about that. But you should know that in either case, the value of A was 10. So let's say that I did not write this line of code over here. Let me comment it out because that's better. And then I delete all this. Right, so we just have A. We just have A. Now I have updated the value of A plus plus. So let's run this. It should return 10. So we have A as 10. And when we bring the plus signs in front and run it, it should return 10 as well. Good, 10. So you should know that if you are declaring it just in one line, the change is going to be the same. But if you are assigning it to a new variable and you want to use that value later, be careful that you have your desired effect. Good. So now the next thing I want to look at A contains then. Okay, so this was just an explanation. And now we want to look at relational and comparison operators. So what are they? We have the equal to, and we have the not equal to, less than, greater than, less than or equal to, greater than or equal to in all of these ones. So now let us illustrate them with examples. What these do is that they compare single values and variables. So let's say for instance I have cout 5 equal 5. Let's print this out and see what the value is going to be. Whoops. And we have error, no match for operator equal. Let me put this in bracket. Right, we run this again and we have 1. Good. And we know 1 is true in programming and 0 is false. So 1 returned here means that this statement is true. 5 equal 5 is true. That means 5 is exactly 5. That's what it means. And you should know that when I did not include the parenthesis, an error was thrown. So always make sure that you include parentheses in this relational and comparison operators when you're using them. Right. Note that 1 is true and 0 is false. So we'll go ahead and then change this to 8. So 5 equal 8. Is 5 equal 8? No. So obviously this should return a false value, which is going to be 0. Right, and we have a 0 over there. Good. So we want to use the not equal to. So if we use the not equal to, we should have a true because 5 is not equal to 8. Right, so the true is 1 over there. Good. Then we have the less than. So 5 is less than or equal to. No, let's use 5 is less than 8. Right, so I would run this and it should be true because 5 is less than 8. Right, and this is true. So you can go ahead and have practice with less than or equal to. Yeah, and see what the outcome is going to be. Now the next thing is we want to look at comparing expressions. So over here we just compared single values, and let's use variables as well. So let's say we have int a and b, right? I initialize them, then I want to say a is equal to 7 and b is equal to 8 or anything. We can say 54. It doesn't really matter. So over here I'm going to compare a and b. So let's say a is less than b. So that means 7 is less than 54. That should be true. Or let's say 7 is less than or equal to, or equal to. Let's run this. This should be false, so 0. Whoops, what did I do? Okay, so we have 7 is less than or equal to b, yeah, and that's true because 7 is less than 54, even though it's not equal to, but it's less than, so this is true. At least one condition is met, right? We'll look at some logical operators later on, and or in all of those ones. But right now, just know that when one condition is true, then it returns true. So 7 is less than or equal to 54. 7 is less than 54, so it's true. So it returns true. So then that is using single values and variables. We use the variable over here. So I would go ahead and then let me just copy this, copy, and then let me cut it and then paste it over here. Right, so what we want to do over here is comparing expressions. So let's say that a is 5 times 8, which is going to be 40, minus let's say 8. So that should be 32. So this value should return 32. So let's just write here, returns 32. And b is going to be anything, 8 dividing 4, which is going to be 2, times 5. So this should return 10, right? So now what we want to do is comparing expressions. So we want to replace this a over here with this entire expression. I just wrote this out. If we put in a is less than or equal to b over here, that means you're using variables, which we have already used up here. I don't want to use variables. I want to use the explicit expression. So I'll copy this and then paste it over here. Right. So then I would comment out this and this as well as that. So we just have a single expression and we are comparing it to another expression. So let's run this and we have 0 returned. That means false. Now let's compare that. So 32 is less than or equal to 10. Obviously 32 is not less than, so it should be false, right? So this comparison is right as well. So you can compare expressions, you can compare variables, you can compare single data types, right? That's it for the relational and comparison operators. Now we want to talk about logical operators. What are they? And these are the not, the, yeah, this is the not and then the and or operator, right? So let's quickly look at the not operator. And quotient should be taken over here. Now we have this value over here. Let's say we have the expression 77 is equal to 77, equal to 77. We know that this would evaluate true, right? So let's create something for it so that we would better understand it this way. So we can have a Boolean value. This is going to be a Boolean value. Let's say person A is equal to, and you know it should always be an expression, 7 in parentheses, 77 equal 77. So we know that this is going to evaluate true and it's going to be a Boolean value, right? So this is going to be 1 true. This is where the Boolean value comes in. Finally, we've used a Boolean data type as a variable, right? Now this is person A and person B is also going to be a Boolean equal not. So we have not person A, or let's just say not 77 equal, so that we better understand, right? So then we want to print out the value of person A. I would explain later if you don't really get what we're doing right now, right? So let's print out the value of person B. So shift B and it returns a false. So 0 over here return meaning false. So that means this statement is false. Now what we should look at over here is person A is saying that 77 equal 77. So this evaluates true, right? This evaluates true. But then person B is saying that whatever person A said is false, is not true. That's what person A is saying. So let's use a second example so we can see, probably we would better understand over this. So I'll cut this and then paste it over here so we can use that one. Right. So now person A is saying that 8 is greater than or equal to 90. Does this evaluate true? Is 8 greater than or equal to 90? This is going to be false. Now, what B is saying is that whatever person A was saying is not true. So let's run this to see what the output is going to be. So we have, I think this thing is still running. Right. So let me clear this and then rerun it, Shift B. And we have 1 returned. That means that what person B is saying is true. So this entire statement is true. So I don't know if you get the intuition over here. Person A is saying 8 is greater than or equal to 90. And this entire statement is a false statement, right? So if person B is saying not what you are saying, then that means that person B is telling us the truth. So I'll go ahead and clear this, and then I'll just use a simple syntax, simple format, so that you guys would see what really is working over here. So if, let's say, whatever person A is saying is true, right? Let's say that whatever thing person A is saying is true, 5 equal 5, 8 is less than 9. All those statements are true. So if whatever person A is saying evaluates to true, and then person B is saying that not true, right? That means not whatever person A is saying. Let's run this and see what the output is going to be. So it returns 0. That means person B is false, right? So then we use a case that person B told us a lie. That means false. And then person B says that not false. So then let's run this and see what person B says is true or false. So if person A tells us lies and person B comes to tell us the truth, obviously person B should be true. So you pick the true over there because person A was false. I hope you get the intuition over here. So let me just summarize this. So if A tells us the truth and B says not true, right? If B says not true, then this should evaluate to false. So these are the only two occurrences. Not true and then not false. So in a case where person A tells us the truth and person B says not true, then that means person B is false. But then if person A tells us false statements and person B says not whatever A was saying, obviously this should evaluate to true. Right, so the next thing we want to look at is the AND operator. And the AND operator is equally under logical operator. So we have the NOT operator, we have the AND operator, and we have the OR operator. Right, to illustrate these operators, the AND and OR operator, I prepared a table for you guys. So go ahead and look at that table. Now what this table is saying is that, let's say we have two friends, A and B, and in house A, where friend A is, they are let's say the two friends are planning a party, right? And so they went to ask their parents whether they would give them the permission to hold the party at their house or not. Now let's go to house A and see the situation. Now in house A, the parents are quite stern and they must both agree before the party holds. So friend A went to his or her parents and told them that he or she wants to hold a party. Let's just say that the friends are boys, so I just use one pronoun. So he went there and told his parents that he wants to hold a party in the house. Right. Now the condition is that both parents must agree before the party holds. in that particular house. So then the mom, well, let's look at their replies. So after he tells them, the mom said yes. The mom agreed, but then the dad did not agree. So will the party hold? No, it will not hold because the two parents must agree. The two parents must agree before the party holds. Now, let's look at the second case. The mom says, no, this party will not hold. I don't give you my consent. And then the dad says, oh, yes, you can hold it. In that case, the party will not still hold because the mom disagreed. Right. The only case the party can hold is when the mom says yes and the dad says yes as well. In that case, the party can hold. That is using the AND operator. So this is the AND operator over here. I should have included it over here. So this is the AND operator. The mom and dad must agree. I think it's over here, but I failed to highlight it. So this is the mom and. So let me bolding it, highlight, whatever. So this is the AND operator. Mom and dad must agree. Now let's look at the OR. Either mom or dad must agree. Right, so only one needed over here. So the second friend B, who lives in house B, went to his parents and told them he wants to hold a party in the house. Now the mom says yes, but then the father said no. Will the party hold? Yes, it will hold because that friend only needed one parent to agree. So if one parent agrees, either the mom or dad, it doesn't really matter. The party would still hold. Now, the second case is the mother said, no, I will not agree for you to organize that party here. But the father said, yes, you can have that party here. Will the party hold? Of course, yes, it will hold because one parent agreed, the dad agreed. The only case the party will not hold is when the mom says no and when the dad says no as well. Then the party cannot hold, right? So I hope this clarified the AND and OR operators. For the AND operator, both must be true. Both parents must say yes. Both must be yes and yes. Both must be true. Both statements must be true in order for the outcome to be true. In order for the outcome in this case to be yes, both parents must agree. But for the OR, one statement only has to be true for the entire outcome to be true. So one parent only needed to say yes for the party to hold. So one parent said yes and the party held. Now, it will be good if let's look at this last case. If the mother said yes, and then the father said yes as well, I should have included it, and the father said yes as well. Will the party hold? Of course, it will hold because both parents said yes, right? So that is the various. And I think I should have a third case here where both said no, no. Obviously, you should know what would happen. So no, no would obviously return a no. So that is the various conditions and the various circumstances of the AND and OR operator. So we would come over here and then use real expressions. But I hope that example was intuitive for you guys to really get to know what's going on over here. Now let's look at this. So let's say we have a boolean integer and it's a, and it's equal to restoring 5 equal 5, right? And then we have a second bool which is going to be b, and in there we're going to store 3 is greater than 6, right? Now what is going to happen here? What does this evaluate to? 5 equal 5 is obviously true. 5 is 5. And then what we have here is 3 is greater than 6. This is going to be false, right? This is a false statement. 3 is less than 6, it's not greater. Good. So now in this case, one statement is true and one statement is false. Now when we run cout and we say want to print A and B, right? That's the AND operator. We're using the AND operator. So A and B, we're printing that. Good. Before we even print out, let's see if we can come up with an outcome. Now the AND operator needs both of the conditions to be true before the entire thing evaluates true. Now 5 is equal 5 is true. That's A. That means A is true. But B is false. So that means the entire thing is going to be false because we need both of them to be true before the entire thing becomes true. So if one is false, everything becomes false. So if one parent doesn't agree, then the party will not hold. Both parents must agree. Take note of that. So let's run this and see what the outcome is going to be. And we have a true returned over there. Why is this true? So A is true, but then let's see what B is. And B is false. Right, so A and B should be false. Oh, I need to put it in brackets. Right, so we get a false over there. So when we leave out the parenthesis and run this, we get a true. This is a semantic error. But when we include the parenthesis, that means that we are covering the entire statement, and we run this, we get a false statement. So then we use the OR operator to see what the outcome is going to be. And it's just denoted by two straight slashes like this, two vertical lines. This is the OR operator. Now you should know that for the OR operator, we just need one to be true for the entire thing to be true. So let's run this code and see what the output is going to be. So we have this returning true because one statement was true. Right. So what if both statements are false? Let's say 5 is equal 9, which is a false statement. So replace this with false. Right, so both statements are false. Now let's say A and B. Obviously this is going to be false because none of the two of them are not true. So this is going to be false. So let's run this. Right, so it returned false. Good. So you can go ahead and then experiment with the other cases. So you can have values over here, and then you evaluate where one statement is true and one statement is false, and you are using the AND operator. Then you can put in a situation where this statement is false and the second statement is true while using the AND operator. So you can go through this entire table to verify these values for yourself. Right, and leave a comment in the comment section. Right, so that'll be it for this video. I think, yeah, that's the entire notes that I have. Right, so take care and see you in the next video.